Hey guys, welcome back to Helper Function. In this video, we will discuss a popular linked list question, Palindrome linked list. So the problem statement is pretty straightforward. Given a singly linked list, we need to determine if it is a palindrome or not. So if it is a palindrome, we will return true, otherwise we will return false. Now what is a palindrome? A palindrome is a sequence of numbers that reads same backward as forward. For example, 1 to 1. So if we read the sequence 1 to 1 from forward or from backward, they are same. Another example is 3 2 to 3. They reads the same backward as forward. And now we are given these sequence of numbers as a linked list and we need to determine if it is a palindrome or not. So for this example, as they read same from forward and backward, that is 2 3 3 2, this linked list is a palindrome and hence we will return true. So let's see how to solve this. Now one approach to solve this problem would be, we create a linked list that will be the reverse of the given linked list. And now if the list is palindrome, then these two linked lists must be same. So in the next step, we will compare all the elements in the list. And if they are all same, we will return true, otherwise we return false. So for this example, as they are all same, we will return true. Now this approach works fine as the time complexity is order of n, as we are using a single loop. But the space complexity here is also order of n, as we are creating an additional linked list. But we have another approach which can solve this problem in constant space. So let's see that. Now because the palindrome list reads same from forward and backward, we can divide the list into two equal parts. Now if they are of even length, then they can be divided into equal parts, otherwise one part will have one extra element. And now we will reverse the second part. And now if the list is palindrome, these two parts will be the same. So now we will compare these two lists. If they are all same, we will return true, otherwise we will return false. Let's look at this example. So we divided the linked list into two parts, and now we reverse the second part. And finally, we will compare these two lists. And because they are same, we will return true here. Now let's look at another example where the length of the list is odd. Now this time the division will be like this. The first part will have one extra size. Now in the next step we will reverse the second part, but because its size is only 1, it will have no effect. And now we will compare these two lists till we have elements of both lists available. So because 2 and 2 are same, we will return true. Now here 3 is not required to be compared because it will be coming only one time in the list. Except this, all the elements will be coming twice. Thus this problem can be divided into three parts. The first one is to find the middle node and split. Now I have made a separate video on how to find the middle node of a linked list, and you can find that in the description. The basic approach is to use the slow and fast pointer technique, where the fast pointer takes 2 moves at a time and the slow pointer takes 1 move. And whenever the fast pointer reaches null, the slow pointer will automatically be at the middle node. You can check out that video for more understanding. The next step is to reverse the second part. And again, I have a separate video on how to reverse a linked list. You can find that in the description. And finally, in the last step, we will compare these two parts. Now the time complexity for this approach would be order of n, as we will be using single loops for every operation. But the good thing is that space complexity is now of order of 1, because we are only manipulating this list and not using any extra space. So let's quickly look at the code. We are given with this function, and I have defined two another functions for finding the middle node and for reversing the linked list. So for these two function explanation, you can check out my another videos. If the list is lesser than one size, we will automatically return true. Now temp on line number 15 will hold the middle node. So now we assign list2 as temps next. And finally, we split this list by assigning temp next to null. Thus, our first step is done. Now our task is to reverse list2. And that is also done. And we take another pointer list1 which is pointing to head. And now we will run this while loop till list1 and list2 is not equals to null. If at any point of time list1 value is not equals to list2 value, then this is not a palindrome and we will return false. Otherwise, we will keep on traversing. Finally, when one of them will be null, we will come out of this loop and return true as our answer. So this was all about the problem. I put the problem link in the description so you can go and solve it. If any doubt or suggestion, please write in the comment. And if not subscribed to the channel, then please do that. Thank you for watching.